All right, Marco, you asked for it. You wanted a tough question on arithmetic or geometric sequences. Here is one of them. It's an exam question. It's paper one, so it's non-calculator. It is specifically for higher level students. Standard, if you fancy a challenge, then go for it. But HL, have a look at it, have a go, and pause the video. And when you're feeling up to it, then unpause and we can work through this. Okay, it's an 18-minute question. Give yourselves maybe 25, 30 minutes, okay, to have a go at it. Don't spend any longer, but try and, get through as much as possible, okay? And remember, you've got all the tools that you need to solve this, okay? So don't let the look of it freak you out, okay? Good luck. Okay, so hopefully you're all okay. Let's have a look at this. First thing I'm going to do is just take some of this information and write it down. Okay, so we're told UN, if my pen actually works, UN is arithmetic. First term is A, and it's got a common difference of D. So the next term is D. The next term is A plus 2D. I have no idea whether, me writing this out is going to help, but I'm going to do it. The next term is VN. We're not told whether it's arithmetic or anything like that, but we are told that a VN is defined by 2 to the power of UN. Okay, so VN is a sequence that is defined by 2 to the power of this sequence. Okay, so let's have a look. Part 1. Show that V n plus 1 over V n is a constant. So that means if it's a constant, it's just a number, essentially, okay? It's not affected by any variable. So I think the easiest thing here is just to, okay, well, let's write down V n plus 1 is going to be 2 to the U n plus 1, and V to the n is 2 to the U to the n. Okay. Now, I'm going to use my rules of indices. So this is all this stuff comes in. If I've got 2 to the x over 2 to the y, my rules of indices say that that is 2 to the x minus y. Okay, so that's just using my rules of indices. Let's erase that, so I think I'm going to need the space. So this is 2 to the power of un plus 1 minus un. What does that tell us? What is, let's do it in a different color. What is this? What is 2, sorry, not 2. What is u to the n plus 1 minus un? Okay, well, let's think about what this means. This is a term in a sequence. This is the next term. Okay, and it's an arithmetic. Remember, un is arithmetic. So let's pick. Okay, if I pick, say, this term, and I subtract the term before it, what am I left with? Or if I pick this term and subtract the term before it, what am I left with? If I've got any arithmetic sequence, 3, 7, 11, if I pick any term and subtract the previous term, if I pick any term and subtract the previous term, I am just left with D. So u to the n minus 1, u to the n plus 1, subtract u to the n is just equal to the common difference. And the common difference is just a number. So 2 to the power of any number is just a constant. Okay. Okay, part 2. write down. So if this is a write down, it's got to be quite straightforward. The first term of the sequence Vn. So the first term of the sequence Vn is just what V1 is. So that's going to be 2 to the power of, well, n is 1, and it's going to be 1 here. 2 to the power of u to the 1. What are we saying u1 is? u1 is the first term, which is equal to a. That is as difficult as it is. Part 3. Write down a formula for v to the n. So v to the n is equal to u to the n, and it has to be in terms of a, d, and n. Sorry, I just wrote that wrong. So v to the n is 2 to the power of u to the n. Now we know because un is an arithmetic sequence, the formula for un for any arithmetic sequence is first term plus n minus 1 times d. We're told the first term is a. So my formula for v to the n is 2 to the power of a plus n minus 1 d. Hopefully you got it. Now, I'm guessing we're probably going to have to use these at some point. Let's go to part B. Alright, so part B says Sn, sum of the first n terms of the sequence Vn. So it's going to be V1 plus V2 plus V3 all the way up to Vn. Okay. Now we need to find the formula for Sn in terms of a, d, and n. So let's write down what is V1. V1 is 2 to the power of a. What is V2? V2 is going to be 2 to the power of a plus d. What is V3 going to be? It's going to be 2 to the power of a plus 2d. And so on. And Vn is going to be 2 to the power of, we've got our formula for it, a plus n minus 1d. Now, what type of sequence have we got here? What am I multiplying by each time? Let's write this sequence down again. Okay, so here's the sequence written down again, just to have another look at it. This is my first term. Now, using my rules of indices, this is the same as 2 to the a times 2 to the d. Okay. My third term is 2 to the a times 2 to the 2d. This is going to be 2 to the a times 2 to the 3d. And remember, this one is going to be 2 to the a times 2 to the d times 2 to the d. This is going to be 2 to the a times 2 to the d times 2 to the d times 2 to the d, and so on. So what am I multiplying by each time to get my next term? Well, we can see this is a geometric sequence because it's going up by the same ratio and it's going up by 2 to the d each time. Okay, and this is just using my rules of indices, okay? So like that's my first term, second term, which is the same as this one, third term, which is the same as this one, just using my rules of indices. Okay, 2 to the a times 2 to the d times 2 to the d, that's 2 to the d plus d, which is 2 to the 2d. 2 to the a times 2 to the 2d is 2 to the a plus 2d. Okay, it's just using all my rules of indices. And this one here is the same as this one, which is the same as this one. Okay, so we can see it's geometric and with common ratio 2 to the d. And the first term is 2 to the a. So if I want to work out s to the n, I can use my formula. Formula is u1 1 minus r to the n over 1 minus r. Now let's be careful here, because this u1 corresponds to this sequence. So that's 2 to the a times 1 minus r to the n. So that's 2 to the d to the power of n, and divided by 1 minus 2 to the d. So we now have our s of n in terms of a, d, and n. So also just remember that there is another way that you can write this formula. Either way is fine. You could have done your first term and then 2 to the dn, so that's r minus 1 over r minus 1. Okay, that would be fine also. Okay, let's have a look at B part 2. So we are here. Find the values of d for which this exists. So the sum to infinity. Alright. So we know. So the sum to infinity, this is basically what this is saying, okay? So let's just clarify that we know what this means. Looking at I from 1 up to infinity of vi. So that means we've got v1 plus, we're going from 1 up to infinity. So 2 plus v3. And I can't write, well, I'm just going to write plus dot dot dot, because we're going to sum all the way up to infinity. Okay, so this is the sum to infinity. Now we said that the sum to infinity, when does that exist? Well, it exists when, choose a different color, the common ratio is less than 1 or greater than -1. But we said the question is asking, find the values of d for which it exists. Now, what does r have to do with d? Well, r is equal to 2d, so 2 to the power of d, r is equal to 2d. So that is when it exists. Now, that's all very well. But I want to find out specifically with it to do with d, okay, not 2 to the power of d. So let's look at this inequality in two separate bits. Let's have a look at the first part. So I've got 2 to the d is less than 1. How can I solve this for d? Okay, and I'm hearing you all shout, well, if I am solving an equation which has got a power, solving an equation for a power, I need to take logs. So I can take logs of that side, logs of that side. Okay, my rules say, okay, if I've got a power, I can pull it down. What is log of 1? Log of 1, I hear you all shouting, is, should be one that you remember, 0. So d, if I divide both sides by log 2, has to be less than 0. Now if I look at the other side of this, if I look at this part, two to the d is greater than -1. I'm going to take logs again. Log of -1. Now can I do log of a negative number? Of course not. Okay, so there is no solution for this part. So my answer is d has to be less than 0. Alright, so that's B part 2. I'm going to recopy the question so we've got more room. How do I do that? Let me see. Okay, so we are on B part 3. You can see we spent about 15 minutes on this question already. It is a tricky one. Well, it's not too tricky, it's just a lock going on, so we're here now. So we're told that this sum to infinity does not exist. Or sorry, does exist. And is denoted by s to infinity. Okay, that makes sense. Write down the sum to infinity in terms of a to d. Okay, so I'm going to do it over here. I don't want to erase anything, so sum to infinity is equal to the first term divided by 1 minus r. So the first term is v1 over 1 minus r, and r we said is, I think we said 2 to the power of d. Yep, r is 2 to the d. So you can see why it's important to set your work out nice and neatly. And v1 is the first term, which is v to the 1. I'm going to, oops, sorry. Let's go over here. V to the 1 is 2 to the power of a. Oh, come on. So 2 to the power of a over 1 minus 2 to the power of b. That's that one. Given that the sum to infinity is equal to 2 to the a plus 1, find the value of d. So I've got 2 to the a divided by 1 minus 2 to the d, and we're saying that it's equal to 2 to the a plus 1, find the value of d. So first thing I'm going to do is, it's up to you, but the first thing I'm going to do is multiply both sides by 1 minus 2 to the d. Okay, by doing that, I get 2 to a on this side, 2 to the a plus 1 times 1 minus 2 to the d. Okay, now, sorry, that should say a. Neater. 2 to the a plus 1, using my rules of indices, is just 2 to the a times 2. So that is going to cancel with that. I've got 1 is equal to 2 times 1 minus 2 to the d. Divide both sides by 2. Subtract 1 from both sides, so I get negative a half is equal to negative 2 to the power of d. So that tells me that this, and sorry, I know I should be working down the page, but I'm just trying to, I want to make sure that you can see everything. So divide both sides by negative 1. Get down to here. To solve this for d, I am going to take logs of both sides. So d log 2 is equal to log of 1/2. Now this is a non-calculator paper. I am going to get d by itself, divide both sides by log 2. Now in order to show the examiner that I'm really clued in, I can use my rules of logs for the top line. If I've got log of something divided by something, it's well log of the top minus log of what's on the bottom. I've already said today that log of 1 is 0. That is 0. So I've got minus log 2 divided by log 2, which is just d is minus 1, which is quite nice. Alright, part C. Okay, how many marks is this worth? 6, so this is going to be nice. Okay, here we go with part C. So we're told Wn is a geometric sequence with first term P and common ratio Q, and P and Q are both greater than 0. So that's my first term. My second term then is going to be PQ. My third term is going to be PQ squared. My next term is going to be PQ cubed, and so on. So first term P, common ratio Q. Now we're also told we've got another sequence Zn, which is defined by Ln of Wn. Find, sorry, that's a bit messy, Wn. Find the sum from I equals 1 up to n of Zi, given your answer in this form, lnk with k in terms of np and q. So let's look at what this means, my sigma notation. So Zi, we're starting at 1, so it's Z1. The sigma notation just means the sum of, and we're going from 1 up to n, so it's 1, Z1 plus Z2 plus Z3 plus Z4 plus Zn minus 1 plus Zn. And so the first term, Z1, is ln W1. Z2 is ln W2. Z3 is ln W3. All the way up to ln Wn minus 1 plus ln Wn. All right. Okay. Now, using my rules of logs, and this rule in particular, ln A plus ln B is equal to ln AB. So this is the same as ln, I'm adding ln W1 plus ln W2. It's just the same as multiplying the two parts inside. So W1 times W2 times W3 times W4 all the way up to times Wn minus 1 times Wn. And what is W1? I've kind of forgotten now. Well, it's a geometric sequence. Okay, yeah, W1 is the first term in the sequence, so W1 is P. W2 is PQ. W3 is PQ squared. W4 is PQ cubed multiplied by PQ. Now, just being careful here, we're always, the Q is always 1 less, the power is 1 less than this number. If this is 4, this is 3. If this is 3, this is 2. If this is n minus 1, it's going to be n minus 2. And then the last term, PQ, n minus 1. Okay, can we tidy this up? I've got how many p's here? I have got n of them. I've got n p's, so it's going to be p to the power of n. How many q's have I got? Well, I've got, so this one is more tricky. Let's just write it out. I've got q times q squared times q cubed all the way up to q to the n minus 1. Okay, now this is where it gets interesting because, oops, sorry. This was q to the minus 1. Okay, and if you're just thinking about, do I need brackets in here at all? No, because I'm just multiplying all these things together. So I've got ln p to the n, and what I'm going to do is I've got q I'm not sure I would want to do that actually. Let me just erase that for a second. Sorry, so we've got q, and I've got, if I write it in terms of my going back to my rules of indices, this is the same, so q times q squared times q cubed and so on up to q to the n minus 1. It's the same as if I am adding my indices together. So q to the power of 1 plus 2 plus 3 plus 4 all the way up to n minus 1. And let's have a look at this stuff, okay, in the brackets. What have we got here? We've got 1 plus 2 plus 3 all the way up to n minus 1. That is a arithmetic sequence, okay? Can I come up with a nice formula for this? Yes, I can. I've got n minus 1 terms. If I want to work out the sum of all these terms, it's going to be n minus 1 over 2. And the first term plus the last term. First term plus, and the last term is n minus 1. So my 1's are going to cancel, and I'm left with n bracket n minus 1 over 2. Okay, that's just using my formula for the nth term for the sum of a arithmetic sequence. Okay, this is arithmetic, common difference of 1. Okay, this is my first term, this is my last term. Okay, I want to find the sum of all of these terms, so it's the sum of the first n minus 1 terms. Okay, so just to recap, it's n over 2, first term plus last term. But I want the sum of the first n minus 1 terms in this case, so that's why it's n minus 1 over 2. First term is 1, last term is n minus 1. And that gets me down to here. So substituting that in, I've got ln p to the n and q to the power of, okay, and this whole sum is equal to this, n bracket n minus 1 over 2. And I think that is us. Let me just check the question. Yeah, find us giving your answer in ln k with k in terms of n, p, and q. So I've got it in terms of, it's ln of k, and k is in terms of p, n, and q. Wow, okay. Have a look at it. That is tough, especially that last part, especially going from this last line down to here. Make sure, a good idea is to work through all of this question again, okay? Give yourselves a day or two and then come back to it, have another go at it, okay? And just so you're aware, going from this line to the last line, that is worth 2 marks, okay? So you do have to go from this point to this point, okay? Give me a shout if you have any questions. Speak to you soon.